Curaceus auratus, also known as goldfish, is one of the most commonly kept aquarium fish. They're aquatic vertebrates whose metabolic rates are easily affected by environmental conditions. A goldfish's metabolic rate may be determined by counting the number of times its gill cover beats per minute. In our experiment, we will examine the effects that an increase and a decrease in temperature may have on a goldfish's metabolic rate. It's important to know the effects that water temperature have on a goldfish's metabolic rate so that limitations may be known and that they are kept in the best possible environmental conditions at our homes. Rapid changes in temperature can kill them, and they can't live well in temperature under 10 degrees Celsius and above 30 degrees Celsius. We predict that the goldfish's gills will open and close at a faster rate in warmer water, thus a higher metabolic rate than in the colder water. This is coined from the known fact that organisms typically move more in warmer climates, thus causing their metabolic rates to increase. Also, at increased temperatures, chemical reactions proceed faster, thus resulting into a higher metabolism. First, set up 9 1,000 milliliter beakers and label 3 of them as control with a temperature of 18.3 degrees Celsius, another 3 as warm with a temperature of 23.5 degrees Celsius, and the last 3 as cold with a temperature of 13 degrees Celsius. Each beaker in each set should be labeled 1, 2, and 3. These will keep track of the 3 different trials and fishes that will be used for each temperature. Pour 600 milliliter of water with a room temperature of 18.3 degrees Celsius in the control beaker that is labeled with the number 1. Stir for 30 seconds to ensure temperature consistency. Put the first fish in the beaker and allow it to adjust to the temperature for 1 minute. After 1 minute, begin counting the number of breaths the fish takes by counting and recording the number of times its gills beat for 1 minute. After recording the first fish's metabolic rate, place a different fish in the beaker labeled as control with the number 2. This will be your second trial for the controlled group. Each group, normal, warmer, and colder beakers, will have 3 different trials. Repeat steps 3 to 6 for all trials. Don't forget to change the water's temperature in accordance with the labels on the beaker, and make sure to use a different fish for each beaker, thus accounting to a total of 9 goldfishes in this experiment. After experimenting, we found that the breathing rate of goldfish was significantly higher when they were left in the warm water with a temperature of 23.5 degrees Celsius than in the control water of 18.3 degrees Celsius. The fish in the colder water with a temp of 13 degrees Celsius also showed an increase in breathing rates, but the change was less significant. The average breathing rate for goldfish in the control water was 67 breaths per minute. The average breathing rate for goldfish in the warm water was 127 breaths per minute, and the average breathing rate for goldfish in the cold water was 79 breaths per minute. The breathing rate from the control to the warm water went up by 190%, and the rate from the control to the cold water went up by 118%. With this, we may conclude that abnormal temperature in general causes a goldfish's metabolic rate to increase. Our results clearly show that the goldfish's metabolic rate increased in both warmer and cooler water. However, the fishes in the warmer water had the highest metabolic rate. These results seem to be logical because as the temperature increases, the amount of thermal energy increases and the cell enzymes become more active, thus causing the fish to burn more calories and the gills to open and close faster. Earlier, we predicted that the fish would have a higher metabolism in the warmer water. This is proven to be correct because our results showed that the fish had the highest metabolic rate in the warmer water. This data matters because it gives us an accurate example of how the water temperature affects the metabolic rate of goldfishes. Because environmental conditions impact the operation of an organism's organ systems and essentially the organism, it is important to be aware of certain limitations when it comes to water temperatures in a goldfish's environment. This experiment also gives rise to new questions, such as, what is the highest and lowest metabolic rate that a goldfish can endure before it dies? To what extent does a fish's metabolic rate rises while people are present? How long is a fish expected to live in an environment with abnormal temperature? Surely for aquarium fish, the conditions inside the aquarium easily affect the goldfish. But how will the fish react to dramatic changes in the conditions outside of the aquarium? The answers to these questions may easily be acquired through research. But if you're motivated enough, perhaps it is your turn to conduct another experiment.